we have Fourier cosine series of an even function. Our main formula for a Fourier cosine series, we have c of x is equivalent to a sub 0 plus the summation of a sub n cosine of n pi x over L, when we have here n is equivalent to 1 to infinity. So this is the major formula for Fourier cosine series. And then we have here a sub o. To find a sub o, this is the cosine coefficient. We have here a sub o is equivalent to 1 over L integral of 0 to L f of x dx. Your f of x is your function. This is the case where n is equal to 0. That is why we have here a sub 0. And then a sub n, we need a sub n here for our c sub x cosine series. We have 2 over L times the integral of our f of x cosine of n pi x over L dx with limits from 0 to L. And then this is the case wherein n is not equal to 0. That is why we have here a sub n. Now we will have an example for Fourier cosine series. We have here, find the Fourier cosine series of f of x equals x squared on x is greater than or equal to negative L and less than or equal to positive L. So to find a sub o, we have our formula, which is 1 over L integral of f of x dx. So we will substitute the value of our function f of x as x squared. So we will substitute here x squared dx, which is equivalent to the integral of x squared is equivalent to x cubed over 3. So 1 over L, we have this one, and then substitute the value of x as your upper limits, that is L cubed over 3, which is equivalent to, we cancel L, so what remains here is L squared over 3. So that is how we find the value of a sub 0. Then this time a sub n, we have here 2 over L, our main formula for a sub n, 2 over L integral of f of x cosine n pi x over L dx. So we will substitute the value of f of x, which is equivalent to x squared. We have this one. So if you have noticed this x squared cosine, this is integration by parts. So we will determine our u and then we will determine our dv. So our u for this case is x squared, and then our dv equals cosine n pi x over L dx. So u derivative of x squared equals 2x dx, and our dv, this part we integrate, integral of dv is equal to v, which is equivalent to the integral of cosine is equal to sine n pi x over L times our u here, the derivative of u equals n pi x over L. So reciprocal of that, because it is integral, so we have here L over n pi. So that for this part, integral of x squared cosine, so we have here integral of x squared cosine n pi x over L dx is equivalent to, so we're solving this part only. Okay, our a sub n, take note, our a sub n equals 2L, and then we have this one. So we will solve first this one. So integral of x squared cosine n pi x over L dx, that is equivalent to u times b, that is x squared times L, we have this one, over n pi. We have here n pi, and then sine n pi x over L, we have this one, minus integral of v du. V du, so 2 times L, that is 2L over n pi, and then x, and then sine, so we have here x sine n pi x over L dx. So if you have noticed this one, x sine n pi x over L dx, again we will integrate using by parts, x sine n pi x over L dx. So we let our u equals x, and then our du equals dx. Of course, dv equals sine n pi x over L dx. So that when we integrate our dv, we have here v equals the integral of sine equals negative cosine. And then our u, we have this one, so it's reciprocal, that is L over n pi. So we have our v. Now, we have here x squared L over n pi. We will copy this one, and then sine n pi x over L we have here. And then minus 2L over n pi. So we take integration by parts of this one, so u times v. So that is negative x times L over n pi cosine. So we have this one, negative x L over n pi minus the integral of b du. So minus times the negative, that becomes positive. So we have here positive, and then L over n pi integral of cosine we have here, and then dx over du. So this is now integration by parts for x sine. So we copy this one and then distribute 2L over n pi, negative times negative, that becomes positive 2xl squared over n squared, pi squared. And then cosine n pi x over L. And then negative times positive, that becomes negative. So 2L times L, that is 2L squared. N pi times n pi, that is n squared, pi squared. And then the integral of cosine n pi x, we have here the result, that is sine n pi x L times L over n pi. Our u here equals n pi x over L. Derivative of that is n pi over L. So reciprocal, we have here L over n pi. Okay, after we find the integral of x squared, we will now apply our limits from 0 to L. Because take note, our a sub n here, we have here limits from 0 to L. So 0 to L, x squared cosine n pi x over L dx. So applying the limits, we have here from 0 to L, I am copying this one, x squared L, we have here sine, and then 2xl squared cosine, and then for this case distribute 2 times L squared times L, that is L cube, and then n squared pi squared times n pi, we have here n cube pi cube, and then sine. So our limits is from 0 to L. And then if we substitute our limits x as L, so this one L squared times L, that becomes L cube, and then x will become L, so cancel L, so you have here n pi, that is sine n pi, plus again x substitute as L, so L cube, we have here 2L cube, n squared pi squared cosine n pi, because you will cancel x here as L, substitute x as L, so L over L, so n pi, and then minus, we have 2L cube, and then sine of n pi. You will cancel x when you substitute x as L, so cancel L, and then when you substitute, this is your upper limits. When you substitute 0 as your lower limits, so this one 0 times this one, this becomes 0, and then x as 0, so substitute this one 0, so you will cancel 0, and then this one sine of 0, that is 0. So what remains here is your L only, your limits, upper limits only. So we have this one. And then after we find our integral of x squared cosine with limits from 0 to L, remember our a sub n, we have this one already, so we will multiply by 2 over L. So a sub n equals 2 over L times our integral, so we substitute 2 over L, multiply 2 over L by the result of this one. This is our integration, so multiplied by 2L's, that becomes 2 times L cube over L, so that becomes 2L squared over n pi. And then for this one, if we multiply this one by 2 over L, that becomes 4L squared. Okay, n over n squared pi squared. And for this one, if we multiply by 2 over L, that becomes 4L squared. 4L squared over n cube pi cube sine n pi. So we have already our a sub n. This time, when we substitute the value of n, remember in our c sub x, our Fourier cosine series, our n starts from 1 to infinity. So if we substitute the value of n as 1, for this a sub n, okay, we have for this case sine of n pi. Sine of n pi, if we substitute the value of n as 1, so this is sine of 1 times pi. Pi here is 180 degrees. So 180 degrees times 1, that is 180 degrees. So sine of 180 degrees, that becomes 0. So actually this one will be cancelled because this is 0 when we substitute the value of n as 1. Okay. For this case also, if n equals 1, then sine of 180, that is 0 also. When n is equal, so what remains here is this one only. Also, we have n is equal to 1. So 4L squared, this one is 0, this one is 0. So 4L squared, okay. And then when n equals 1, we have here 1 squared, and then pi squared. This is supposed to be pi squared. Okay, I will write here pi squared. So this is pi squared. And then, of course, when n equals 1 multiplied by 180, so cosine of 180, that is negative 1. Okay, this time when n is equal to 2, when we substitute the value of n is 2, that is 2 times 180, that is 360. Again, sine of 360, this will become 0, and then this one is 0 also. So we will only focus this one. So we have here 4L squared, 4L squared, and then when n is equivalent to 2, 2 times pi, 2 times 180, that becomes 360. If you use your calculator, cosine of 360, that becomes positive 1. So this is the equivalent, positive 1. And then, of course, when n equals 2, so that becomes 2 squared pi squared. This time, when n is equal to 3, again, this will become 0. 3 times 180, that is 180 times 3 to 3 times 8, 24, 540. So sine of 540, that becomes 0. So we will not include again this one. So we will focus only for cosine. So when n equals 3, so 4L squared, and then n equals 3, that becomes 3 squared pi squared. And then cosine of n, that is 3 times 180, that is 540. If we use calculator, cosine of 540, that becomes negative 1, and so on. So if you have noticed this one, we have a constant of 4L squared, 4L squared, 4L squared, so 4L squared. And then we have here our n, when n equals 1, so 1, n squared. When n equals 2, n squared. When n equals 3, n squared. So we have here n squared pi squared. And then for this case, how did we arrive this one? So when n equals 1, we have here negative 1. When n equals 2, we have here positive. When n equals 3, we have here negative. So we have here the case when n, that is when n equals 1, that becomes negative. When n equals 2, this becomes positive. When n equals 3, that becomes negative. When n equals 4, that becomes positive. So we have here our a sub n. So going back to our cosine series, Fourier's cosine series of f of x, which is equivalent to x squared. So we have here c of x squared is equivalent to a sub 0 plus the summation of a sub n cosine n pi x over L, which is equivalent to our a sub 0 equals L squared over 3. We have here a sub 0 equals L squared over 3. And then plus the summation of this one, wherein our a sub n, we find a sub n as 4L squared, negative 1 n squared, pi squared, and then cosine of n pi x over L. Cosine of n pi x over L. So this is our Fourier cosine series of x squared. This is our final answer.